Hi everyone, today I'll explain what a probability distribution is and why it matters in finance. Definition: it's a math function that shows how likely different outcomes are, like stock returns or prices. Purpose: it helps measure risk and uncertainty by turning unpredictable events into numbers. Why it's useful: it estimates potential profits or losses, helps with portfolio planning, prices things like options and futures, manages risk using tools like value at risk, VAR. Key uses: investing, balance risk versus reward, risk management, prepare for worst case, pricing and forecasting. Bottom line: it helps investors and analysts make smarter, data-based financial decisions. Now, I'll be presenting on modeling loan default risk with binomial distribution. This presentation will walk through how financial institutions can use probability models, specifically the binomial distribution, to estimate and manage credit risk. We'll also see how tools like Excel can bring these concepts to life in a practical way. Let's begin with the problem. Banks often deal with the uncertainty of whether or not a loan applicant will default. In this case, we have data from 30 past loans, out of which 7 borrowers defaulted. That gives us an estimated default probability of about 23.3%. Now, the bank wants to evaluate 10 new applicants. Our goal is to model how many of those might default using the binomial distribution. To understand this model, we use the binomial distribution. It's ideal for situations with only two outcomes, like default or no default. Each applicant is treated as an independent trial, and we assume each has the same probability of default. The key parameters are n, the number of applicants, and p, the probability of default. We use the binomial formula to compute probabilities for different numbers of defaults. This model has real applications in financial risk analysis. It helps banks estimate likely outcomes, determine reserve requirements, and set risk-based pricing. Most importantly, it transforms raw historical data into actionable insights, improving financial decision-making. To solve this, we use the binomial probability formula. We're finding the probability that exactly 3 out of 10 applicants will default. So, we plug the numbers into the formula. P x equals 3 equals 10 thirds, 0.233, cube, 1 minus 0.233, power of 7. This becomes 120 times 0.0126 times 0.156 approximately equals 0.237. So, there's about a 23.7% chance that exactly 3 applicants will default. Applying binomial distribution in Excel. We used Excel to apply the binomial distribution formula. First, we input the data and set the number of trials to 30 with a probability of 0.233. Excel calculated the probabilities for different numbers of defaults, and we visualized the results in a bar chart. This helps us clearly see the most likely number of defaults among 30 applicants. Applying binomial distribution in Python. Let's look at how we apply the binomial distribution using Python. In this example, we assume there are 10 loans, and the probability of default is 0.233, based on past data. We use the Skippy stats library to calculate the probability mass function, or PMF, for each possible number of defaults from 0 to 10. The bar chart on the right shows the probability of each outcome. For example, it's most likely that 2 or 3 people will default. This kind of analysis helps banks estimate and manage their loan risks more accurately. Now, how does the binomial distribution compare with others? If the sample size were very large, the distribution might look like a normal curve. For rare events, the Poisson distribution is also used. But when we're modeling a fixed number of borrowers with binary outcomes, the binomial distribution is the most accurate choice. To wrap up, the binomial distribution is a simple yet powerful tool for modeling credit risk. It gives banks a structured way to estimate loan defaults and make smarter financial decisions. With tools like Excel, anyone can implement this approach and gain valuable insights from the data.
Moving on to the normal distribution, it is a continuous, symmetrical, bell-shaped probability distribution that is defined by its mean and standard deviation. It is widely used in both finance and statistics. One of its key features is that the mean, median, and mode are all equal. According to the empirical rule, about 68% of the data lies within one standard deviation from the mean, 95% within 2, and 99.7% within 3. To apply this in a real-world context, we simulated 30 weekly rent values. The mean rent was $480 and the standard deviation was $17.87. Using the z-score formula, we calculated the probability that the rent would fall below $460. The result was a z-score of -1.12, which corresponds to a probability of approximately 13.15%, based on standard normal distribution tables.
Next is student t-distribution. The student t-distribution is a continuous probability distribution that is symmetric and bell-shaped, much like the normal distribution, but with heavier tails. The student t-distribution is widely used in financial modeling as a more realistic alternative. It provides a better fit for data with heavier tails, allowing for improved estimation of risk metrics such as value at risk, VAR. Here is the example of financial problem. Modeling monthly returns of the S&P 500 index with fat tails using the student's t-distribution, and that is the data given from the source. The solution is firstly noted the data from Excel, which is mean, standard deviation and excess kurtosis for monthly return, and then find degree of freedom, V. After that calculate 95% VAR using student t-distribution and normal distribution. Follow the given formula below. Next, compare the final answer. So, we can conclude that the value of VAR are close because the estimated tail thickness is moderate. Using student t-distribution allows for more accurate risk estimation in market exhibiting fat tails. Lastly, simulation comparing the probability density function, PDF, of the normal distribution and the student t-distribution using Microsoft Excel. This comparison is important in financial modeling, especially for analyzing return data where normal assumptions may not always hold.
Combining statistical theory with digital tools such as Excel and Python enhances financial analysis. These tools allow analysts to simulate distributions, calculate probabilities, and visualize risk. The integration of both discrete and continuous probability distributions enables financial professionals to make smarter, more accurate, and risk-aware decisions even in uncertain market conditions. That concludes our presentation. Thank you very much for your attention. Wassalamu alaikum warahmatullahi wabarakatuh.